Hello everyone. Today we are going to discuss an interesting topic, the difference between machine learning and deep learning. This could be confusing whenever you are getting started with machine learning, especially when people use it interchangeably. Right? So there are specific use cases where people prefer machine learning over deep learning, and there are differentiations between each of them. So we are going to understand them today, as well as take a small example and try to implement it with both machine learning as well as deep learning. So the first difference is the algorithms. In case of machine learning, there are different algorithms, but some of them are linear as well as tree based. So the linear ones are linear regression, trees, decision tree, random forest tree, and others. When it comes to deep learning, it's always neural networks which we are trying to create. So the second difference is the type of data we are trying to use for this. If your data is tabular and it's already stored in a database or as a CSV file, that's where we go with machine learning. When it comes to deep learning, the data is like images or audio, which for a human being it's not very easy to differentiate between, right? That's where we have different layers of neuron which automatically learns key features about the images. The next one is also a main difference. In case of machine learning, there would be data scientists who try to extract the important features from your tabular data. So they do feature engineering on the data, and that part is handled by a human before we give it to the machine learning model to learn. In case of deep learning model, similar like an audio and an image, for an individual to find the difference, it's really difficult. That's where the deep learning is coming, and it's really powerful, the way it learns from the data. So that exactly comes to the next point of interpretability. So a machine learning model, because humans are trying to understand what is happening and helping it, we can easily understand what it is doing. I cannot say easily understand, but there are ways to understand what the machine has learned. However, when it comes to these large neural networks like the LLMs and others, it's a black box for the human being. Its networks learns the details. However, when it comes to interpretability, it is really difficult. One another interesting thing for machine learning, especially in case of deep learning and LLMs, is the transfer learning, where you can train a model and later only change some part of it to use it for a different use case. That's not the case for machine learning. You train it for a specific purpose. If you want to retrain it, you have to do it again. Okay? So now let's go through an interesting example where we can see this model in action. So here the data set we are taking is a tabular data. So ideally a machine learning problem, and we are going to try it for both the cases. So our data is different temperatures and sunny or cloudy. Around 30 degree we are saying sunny, 22 and below we are saying cloudy. Very easy for us to interrupt, understand, and same the case for the machine learning problems, right? So the next step we are going to do is convert the data into numeric so that the models can learn. This is same for both deep learning as well as machine learning. They can only understand numeric values. The third here, we are using logistic regression, which is a type of linear model, a simple machine learning model to learn. So at the end, we have got a logistic regression, which is an example of a machine learning algorithm and a model we created. Here we are going to use Tensorflow to do the exact same thing and create a deep learning model. The main differences is here you are seeing we only have a single layer, and the way we train is also a little different. We have to iterate through the data set, but let's keep those details for some time later. And let's see that it's training. We have given 1500 iterations, so Here the accuracy also is increasing. And finally we have accuracy of 100% around, yeah, and the training is also going to finish. Okay, finally 1500 iterations and we got a model. The model is a single layer and it has one input and has two parameters. Okay, now let's try to predict the temperature, I mean the weather, when the temperature is 27. So both of our models, both the machine learning model as well as the deep learning model, predicted it's a sunny day. Now this is the interesting part. We are trying to find what the weight and biases it has learned from both case of machine learning as well as deep learning. If you don't understand what is a weight and bias, we have another video, but in a key sense, it is the values that are being learned is weight and bias in both the case of machine learning as well as deep learning. So these are the values they have learned. So W is a small positive value and bias is a negative value. And if you see, this is the line which it has drawn to differentiate or decide when to predict it as a 1 or a 0. If you see the deep learning line, it's not that good. That's why deep learning models are specifically suited for images, audio, or where there are a lot of data, not these kind of examples, right? But at the end, we can see both how a simple machine learning model as well as a deep learning model works. Coming back to our presentation, I want to conclude by saying deep learning actually is a bunch of simple machine learning models put together. So here we have a 6 layer neural network, and if you zoom in into one of those neurons, it's again a logistic regression. Okay, so in our example we saw there are only 2 parameters, but if we had around 6 layers, we would have around 23 parameters. Even 23 parameter is a very small neural network. To give a perspective, ChatGPT has around 175 billion parameters. I hope this gives you an understanding what is the key difference between machine learning and deep learning. Thank you.